Hello there, my name is Daren May. I'm a developer, trainer, and Microsoft Windows Development MVP. Migrating from desktop-based applications to the web by using the Uno platform is reasonably straightforward. In this short session, we will cover some of the architectural fundamentals and implementation considerations for migrating WPF applications to the web using the Uno Platform and WinUI. In this session, we'll talk about how to get started, some aspects of scoping the migration, as well as some implementation considerations for WPF XAML to the modern XAML, and then we'll demo a migrated application. So let's take a look at preparing for a migration. When I'm thinking about a migration, my key concerns are going to be around how do I maximize reuse, not only of the code, but also my existing skill set. That's where the Uno platform really shines. If you've invested in C#, XAML, and .NET, this is a natural place to go. When I'm thinking about migrating a code base, I typically think about three things. I want to maximize the reuse of the code. I want to refresh where it makes sense if I want to exploit new capabilities in the platform. And I want to rewrite as little as possible. Pragmatically, that looks something like this. Vast majority of your code base is going to move across, be that the existing XAML structure, as well as things like business logic and view models and so on and so forth. You are going to have to refresh some things. For example, navigation has changed a little bit between the platforms, and equally we have access to more advanced binding capabilities using XBind. And there's also going to be some areas that we're just going to need to rewrite. That may be that we have a custom control that leverages specific deep features of WPF that don't exist in UWP. The important thing is to perform your research first. The Uno Platform's application API is compatible with the UWP application API as well as WinUI 3. And it's important to understand the capabilities of those platforms. There are some differences between them and the existing .NET framework libraries. So if you want to use older code, you're going to need to recompile it, and you won't have access to framework-only APIs. The other key thing to think about is a lot of the modern APIs are async only. So if you've made use of synchronous code in your previous WPF applications, you're going to have to take a look at what it's going to take to migrate over to a more of an asynchronous task-based model. In terms of XAML, there's a lot of compatibility between them as they share a lot of common roots. However, some of the more advanced flexibility features in WPF XAML have been dropped in favor of more performance in the modern XAML. The other thing to take into account is the Uno platform has migrated a lot of the APIs over. However, some of them are yet to be migrated, and some of the controls have been migrated with only a few of the available properties. So dig into the documentation. There's a lot there that talks about how to get started and how-tos and so on. But make sure that you have a concrete idea of where you're trying to go and what controls you're trying to use. The key point here is to understand what is supported before you dive in and start building. So now we've got an understanding of what the Uno platform has to offer from a high level. What are the considerations when migrating your app from the desktop to the web? Well, in terms of architecture, we need to think about, okay, how was our existing application built? Did we use MVVM? If so, was it an in-house variant or was it some third-party library? There's great news there in that many of the third-party MVVM libraries have been migrated over to Uno, such as MVVM Lite, Prism, and there's also an existing implementation available in the Windows Community Toolkit for use if you should need to start from scratch. Of course, you can still leverage code behind. The other thing to consider is the navigation style in your previous application. If it was using page-based navigation, great news. That's relatively straightforward to migrate, although there are some implementation changes that you need to take into account. Another area of investment is a lot of custom controls. So you're going to need to look at, okay, how do I migrate those things over? Is there an existing built-in platform implementation of this control that I can leverage and will be better to use? Are there controls available in the Windows Community Toolkit and so on? Also good news, a lot of the WPF applications leverage content controls and data templates to give a lot of variability in the UI. That is still supported over in the modern XAML, although you might want to consider migrating your data templates over to more strongly typed variants to take advantage of the performance that XBind gives you. As I mentioned earlier, we also have the asynchronous pattern that we need to make sure that we're adopting as well as we can. Other things to consider: data access. Many of the smaller WPF applications are often directly connected to databases. You need to consider whether that's still a good pattern to employ. Doesn't really make sense if we're migrating to the web, so we want to look at leveraging web services and so on and so forth. We also need to look at our application. Has it leveraged things like WCF or WCF data services? Unfortunately, those technologies are deprecated, so we might need to consider migrating to gRPC or REST-based services. And a final area to think about is tight desktop integration. You might be leveraging registry access or settings files and so on and so forth. Those things aren't going to be available to you if you migrate over to the web. So now we've looked at architectural considerations from a high level. Let's think about how we can look at some of the WPF XAML features that are missing and some alternative approaches for implementing those features. So there's a great deal of compatibility between WPF XAML and UWP XAML, but some of those features that provided a lot of flexibility have been sacrificed in the name of performance. Particularly if you're looking at binding, multi-binding, priority binding, and the ability to access an ancestor element, those aren't available out of the box. There are workarounds for those things in terms of behaviors that have been provided, but also XBind provides a lot of opportunity with function binding and so on. Some of the more dynamic styling capabilities that style triggers and dynamic resources aren't available to us. Style triggers, for example, are not available. Dynamic resources not available, but there are workarounds for these. An area where there isn't many workarounds is the XAML extensions that provided access to change code generation, such as class modifiers, subclass, and so on. And an area that may particularly bite is if you've made a lot of use of XNull in setting up bindings. That isn't available in UWP. Of course, there are differences in the controls that are available out of the box. For example, WPF has a label control. That isn't available in UWP, for example, but TextBlock is. Also, many controls have built-in header properties that you can leverage instead of label anyway. Things like listbox have been deprecated. It is available in UWP, but list view is now preferred. Data grid isn't implemented out of the box, but is available within the Windows Community Toolkit. I strongly recommend looking at the available resources for the different controls that are available in the platforms, as well as Community Toolkit, and I've left links on this slide that you can go and follow. Now let's take a look at a couple of examples of multi-binding and how we can implement similar capabilities in the modern XAML. So in WPF, we have this string format capability in a multi-binding, which allows us to take more than one binding for, in this case, last name and first name, and then construct a string that gets rendered up as a single text block. How would we approach that in modern XAML? Well, we have the advantage that text block actually allows us to bind to run elements within there. So as you can see here, we have 3 run elements, 2 that are bound to properties and 1 that is just dropping out the comma and a space. And so that achieves the same result. But of course, there's more than one way to achieve this. XBind also introduces the ability to use function binding, where we can have a function implemented in a code behind, or if we're using MVVM in the view model itself. And that allows us to pass binding values, or in fact string literals, into that function to return back similar results. Another aspect of multi-binding is the ability to be able to leverage values from multiple controls and generate a single value out to, in this example, to use the sliders red, green, and blue to change the fill property for the rectangle. If we look in WPF XAML, then what we have here is we have a color converter resource that's declared. Then we have the UI layout, and you'll notice we have sliders and labels, and the sliders are named. And then finally, we have a multi-binding that's setting the fill property of our rectangle. And what we can see there is the multi-binding is monitoring the values of the sliders and passing those into the color converter control resource in order to generate a new color for our rectangle. That converter looks something like this. As you can see, the convert method actually receives an array of values. Because this is loosely typed as an object, we need to make sure we perform some validation to make sure the values are not null, that they're not unset, and so on, before we convert them over to byte values from which we can then generate a color and a solid color brush. So how does this look like in UWP? Well, as you would imagine, the UI looks very similar. The XAML is a bit simpler. We actually don't have to have a custom converter defined, and our sliders have built-in header properties, so we don't need the labels. If we take a look at the fill property, we can see that's using xbind to use a function from values where we can pass in the strongly typed named values from our sliders. If we look at the actual function, we can see that's a lot simpler as well. Because this is strongly typed, we're getting doubles for our values, so we can use those directly in the generation of our color and our solid color brush. Another area that we're missing from WPF is style triggers. So if we look at style triggers, they basically are used to change control properties based upon values or expressions, and they're also used to respond to system theme changes. For example, if we want to display a high contrast version of our UI. UWP has a lot of alternatives for these, of which style selector is probably the most common you'll use. Another area that is particularly useful in responding to theme changes is theme resources. So here's an example of a WPF UI that is using a style trigger to change how items are rendered in a list. In this particular example, any city that is in Washington state is going to be rendered with a foreground of red, and the particular instance of Portland, Oregon is going to be rendered with a cyan background, and everything else is going to be rendered with a default look and feel. So in WPF, we might have a style trigger that looks something like this. We have a data trigger that's monitoring the value of the state in the context. If it's Washington, then it's going to set the foreground to red. Then we have a multi-data trigger that is using two conditions. One is the city equal to Portland, and is the state equal to Oregon. And if so, it's going to set the background property to cyan. In UWP, if we're going to use a style selector approach, we need to have multiple styles, one for each of our scenarios. For example, we've got the Washington style that has a foreground of red, and then we've got the Portland, Oregon style that has the background of cyan. We then create a static resource using a custom selector, and we pass in those two styles. In terms of implementation, it's pretty straightforward and looks somewhat similar to the logic we expressed in our data triggers. We're implementing from style selector. We have our two properties for our various styles, and then we're overriding select style core, which is then evaluating our business logic. We're getting passed in the type that is being displayed. So we've got item, we're casting that over to our city state, and we're then checking the values. If the state is Washington, we're returning the Washington style. If it's Portland and it's Oregon, then it's going to return the Portland, Oregon style. Otherwise, it's going to return the default style for the item. In terms of how we would use this, for example, here's our list view. We have a attribute item container style selector, which we can specify the custom style selector we want to use. And this will render out the same output as we saw in WPF. Coming on to themes. Themes are a very powerful capability in modern XAML. So in our WPF application, by default, it would look something like this. And if we switched our system over to high contrast, then the theme would change to display this sort of content. In terms of the WPF implementation, we've got a style trigger here that's looking specifically at the header style. And you'll notice we've got style triggers and a data trigger that is monitoring the system parameters high contrast. If that gets set to true, then it's going to change the values for the label foreground and background to use system colors. So how would we go about approaching this in UWP? Well, UWP has this concept of theme dictionaries, which are a collection of resource dictionaries specific to a particular theme. In this example, we have 3 dictionaries for dark, default, which matches our light theme, and high contrast. Within each of these dictionaries, we've specified the same resource but different color values for it. For example, white on our dark theme, a blue color on our light theme, and then we're leveraging another theme resource, which is a predefined system color button text color. That ensures that we're maintaining our best practices around having high contrast colors. In terms of how we would use this, we'll have our style again for our header text style, and instead of specifying a static resource, this time we're specifying a theme resource which will be updated dynamically should the system theme change. So as an example, here is our WASM version of our application running in light theme, and then the system's been switched to high contrast and we can see the colors have changed. But of course we also can support a dark theme, and so our dark theme looks somewhat similar to the high contrast in terms of colors, but we have a much richer color palette available to us. So that's enough of the slides. Let's take a look at a migrated application running in WebAssembly. So let's take a look at the WPF application that has been migrated. Very simple. It's a straightforward 2-page application, uses the navigation frame, has a list of users. I can select a user, hit view, see the expense report for that user, and hit the back button to return back to the home page. Let's now have a look at the Uno version of this implemented as UWP. So as you can see, very, very similar UI. We have a list of users. I can select view, navigates to the expense report page. I can hit back and return to the home page. You may have noticed as well that there are transitions as I navigate between pages and as these items load. Now let's have a look at the same application running as WebAssembly. Open up my browser, browsing to a local source, splash page, and so again you can see a lot of consistency between the look and feel between the WebAssembly version and the UWP version of the migrated Uno app. I can select a user, hit view, see the expense report, see the information loaded, and hit the back button to navigate back. One thing you may notice is that transition animations between the views isn't supported. Now let's have a look at the Visual Studio solution that supports this. In my solution, I have 2 solution folders, one for the original WPF application and one that contains the Uno projects. WPF application was created using the .NET framework, could just as easily be .NET Core, very, very similar. Down here we have 3 projects. We have the shared project, which is where we do most of the work for migration, and we have our 2 heads, one for the Universal Windows application and one for WebAssembly. If you were using WinUI, you would have obviously a Windows desktop target, and also by default you would have other platforms such as Android, iOS, macOS, Tizen, and so on and so forth. I've deleted those because they're not relevant to my particular scenario. If we have a look at the actual structure of the WPF project, we can see we have app XAML, which defines the application. We have 2 navigation views, expense at home and expense report page. We have a main window which provides our Chrome for navigation. We have a styles dictionary, and we have the watermark file. If we come down to our shared project in the Uno project, we have a very similar structure. We have a few additional folders. We have assets, which is by convention where we put things like our watermarks and so on. I have a models library, and I'll come back to that in a moment. I have services. This is again something that I've added as a place to encapsulate where my data is. We have strings, so this is created by default and is a resource table for strings. And then we have our main application structure. So again, we've got our application definition, we have our 2 navigated views, and we have styles. When we look at the application XAML for WPF, what we see is it's pretty simple. We have a startup URI that tells the application that the first view to be displayed is main window. We also merge in our styles dictionary. Comparing that to the app.xaml in our shared project, it's very, very similar. We don't have a default URI because we're actually going to direct that in code. But again, we merge in our resource dictionary as well as the WinUI styles. If we have a look at the code behind for the WPF app, what we see is it's effectively an empty template. All of this startup is specified declaratively in the app.xaml. Of course, there's many things we could add to this, and in most non-trivial applications, you would have things in here for startup and so on. If I look at the same file in our shared project for Uno, we see there's a lot more code in here. Now, of course, I didn't need to write all of this. This was actually part of the boilerplate that's provided when we actually create an Uno project. It has things in here that detect different platforms and so on, because obviously this supports multiple targets. It needs to be able to support startups in different platforms such as Android, iOS, and so on. The key area I want to show you right now is during startup, we get hold of our current window and we look to see whether its content is an existing frame. That would be the case if the application was already running and we were re-entering a running application. If not, we create a new frame. This frame performs a similar purpose as the main window in our WPF application and is the host of our navigation, if you like. Once we have our frame, this is how we actually navigate to our home page. So this basically says root frame navigate to the type expense.it home. The infrastructure behind this creates an instance of expense.it home and displays it. So there's a little bit of difference on how the application starts up. Now let's have a look at the expense.it home in the WPF application. If we take a look at this, we can see its overall structure is pretty straightforward. We have resources, we have our grid that's defined, which defines our layout of columns and rows, and then we have the controls that are displayed within. If we look at the same page in our shared project, we can see a very similar structure. If we collapse down our resources, we've got our background image, we've got our layout definitions, and we've got our controls. Now we are using text blocks instead of a label, borders the same, we're using a list view instead of a list box, button is the same. So you can see how a lot of this layout code can be copied straight over from the WPF application into our shared project. If we come back to the expense.it home, in the resources, we do have something that isn't available in UWP, which is the XML data provider, and we're using XData to specify XML that defines our displayed data. We can do something very similar in the UWP XAML by using the fact that XAML itself is an object instantiation framework, and we can specify our objects and supply properties and so on. These models have to exist as classes and they're defined in our models directory. So we could use this as an alternate approach to achieving something similar in terms of embedding the data within our XAML. I personally don't really like this particular approach. I prefer to have a separate service that has my data in it. So this is just a simple class that has a static list of data that I can then bind to. But your mileage may vary. Now let's have a look at the styles. So if I open up the styles dictionary on the WPF side, we can see that we have this definition of a header style. We actually have many styles in here, but we'll just focus on the header text style. So taking a look at the header text style, we can see that we have setters for label, vertical alignment. This is because this style isn't targeting a particular control, so we're specifying the type of control here by saying label dot. In our UWP styles resources, we're always going to be specifying our target type, so we don't need to have this, and actually this isn't supported as a dot notation. We then specify things like our colors, and then we have this style trigger that we mentioned earlier in terms of responding to system theme changes. If we look at the styles in our UWP application, we have our resource dictionaries that we're using for themes. So as mentioned earlier, we have the ability to specify resources that change depending on whether we're dark theme, default theme, or high contrast. I like to centralize my resources into specific colors and then give them useful mnemonics that I use throughout my styles. But here is the UWP equivalent of the header style. Notice it's targeting a text block, so we don't have text block.vertical alignment and so on and so forth. And then we're specifying a theme resource for our colors. This makes it theme responsive. So let's have a look at our applications running again and see what happens when we change our theme. So if I bring up the system settings, I can change our theme from the light theme to the dark theme. So I'm going to click this, and we can see that immediately our web application has picked up our changes. We can also see that our UWP application has now picked up the changes. And of course, WPF has no concept of the dark theme and so hasn't changed at all. I hope this gives you some insight into some of the capabilities that are available using WebAssembly with the Uno platform. In this session, we've looked at migration concerns, key aspects of reuse. We've emphasized the importance of research and how that plays into looking at our existing architecture and coming up with an architectural roadmap of moving forward. And then we've looked at key aspects of XAML compatibility on migrating your application over to the Uno platform. Thanks very much for watching.